All right, little skills practice with exponential growth and decay. For problems 6 through 9 here at the beginning, first we're going to decide if it's growth or decay, and we're going to state the percent increase or decrease. So in number 6, you see that inside it's less than 1, so this is decay. Now, if you take 1 minus 0.9, you get 0.1. That means this is a 10% decrease. In this one, 3 is greater than 1. So this is growth. And recall that our growth factor is 1 plus the percent increase. So 3 equals 1 plus x, so that means 2 is x. This is a 200% increase. Inside is positive, right? Greater than 1. This is growth. Again, growth factor is 1 plus percent increase, so 2 equals 1 plus what? That means x is 1, 100% increase. Less than 1. This is decay. Sometimes let me go to the same concept here, where the decay factor is 1 minus percent decrease. So 0.6 equals 1 minus x, negative x equals 0.4, negative 0.4. So this is a 40% decrease. All right, story problems. Your local drugstore has determined that zombie preparedness kits, for whatever reason, aren't selling. So the store manager is putting them on clearance. Right now, the zombie preparedness kits cost $40. Every week until they're gone, the store will discount the current price by 15%. Write an equation. Well, $40 is the starting price. They're going down by 15%, so that means we have 0.85 in here, because 1 minus 0.15 gives us our decay factor to the x power, where x represents number of weeks. After 7 weeks, what's our price going to be? Well, if I have y equals 40 times 0.85, x represents number of weeks, so I plug in the 7 for x. After 7 weeks, the price will be $12.82. How long will it take for the price to drop below $6? Okay, remember, after 7 weeks, the price is $12.82, so it's got to be more than 12. So again, don't forget what your model is, because you are going to need that. Let's start with 10. If x equals 10, 40 times 0.85 to the 10th, my y value is going to be 787. Too high. Okay, so I'm going to go with 12. So 40 times 0.85 to the 12th, I get 568. Right? Too low. So maybe. So if I go 11, right, go in between them, 0.85 to the 11th, I get 669. So that's too high. It's got to be 12 weeks, because that's when it falls below $6. Number 11, Cassidy, an amateur investor, makes several investments with her family's disposable income. Who has disposable income? She convinces 2 family members to invest and notices the following. Construct a model for each one. Okay, mom's got $2,000 growing at a rate of $200 per month. Okay, every month is $200. This is a linear model. $200 per month it's going up. So $200 per month, and she started with $2,000. Mom is a linear growth. Dad decreases by 2%. This is exponential. He starts with $13,000. Who has $13,000 of a disposable income? What the heck? Decreases by 2%, 0.98. X, where X is each quarter. Right? Remember, quarter, there are 4 quarters in a year. We're going to need that later. Cassidy uses her own $2,500 and increases by 5 1/4. I like how Dad's losing money and she's making money. That's fair, right? So she starts with $2,500, increases, wrong button, by 5 1/4%, where X is the number of years. So let's go ahead and simplify 1.0525 raised to the X, where X is, again, number of years. Okay. How much is Dad's account after 2 years? Okay, now remember, Dad is in quarters. So in 2 years, there are 8 quarters. So X equals 8. So we're dealing with Y equals 13,000.98 to the 8th power. After 2 years, he has left $11,059.92. Right? You lost almost $2,000 in 2 years. Sucks to be you, yo. 13. How much does Cassidy have after that time? Well, she's in years, so X is just 2. So 2,500 1.0525 to the second power, and she will have 2769.39 after 2 years. So Dad lost $2,000 and she gained $269. Yeah, it's not quite even. When does Cassidy's account overtake Dad's? Now this is a guess and check method, okay, and it took me a long time. So let me just get to the business of it. 13 years. For Cassidy, at 13 years, y equals 2,500, 1.0525 to the 13th power. Her value is 4862. Now, for Dad, after 13 years, remember 4 quarters in a year, that's an x value of 52. Let me double check my math and make sure I'm right here. Yeah, I'm good. Okay, so he was at 13,000.98 to the 52nd power, and that gives us 4546. So you can see that Cassidy's value is now greater. So if he just let it ride for 13 years at this decrease, hoping it was going to bounce back, after 13 years, she officially has more money, and he has lost a ton. All right, let's go to a new problem. Arca and Casey have just gotten married. Congratulations. They believe that in 5 years, they'll have saved enough to trade in one of their old vehicles and purchase a new one. Arca paid $21,900 for his car 8 years ago, and he figures it is depreciating at 16% a year. All right, so she's had this car, or he. I don't know who's the female and who's the male in this problem, or they're both female or both male. Who knows? We have 2 people. I guess we'll call them A and K. So Arca paid $21,900. Oh, his. There you go. His car 8 years ago, and it's depreciating 16% a year. So $21,900. Depreciating at 16%, so 1 minus 0.16, that gives me a decay factor of 0.84 T years. So here is Arca's model. How much is Arca's car worth now? Okay, now they said 8 years ago, so X equals 8, or T, I meant T. T equals 8. So Y equals 21,900 times 0.84 to the 8th power. Arca's car right now is worth $5,428.48. Not bad. If you want to trade that in, you're going to still get some value out of it. Okay, Casey doesn't know the rate for her car. Oh, hey, there's the female. But she does know its value for the year she's owned it. I don't know how she would know that, but whatever. Absolute relative change. Remember, absolute, I didn't want that to be an A. New minus old. Relative, new minus old divided by old. So for year 1, 14,240 minus 16,000 gives me negative 1760. I take that negative 1760 and divide it by the old value of 16,000. Whoa, 1 too many zeros. And I get a value of negative 11%. Hit pause, complete the table, come back, check it out. All right, so you can see each year the absolute change differs, but the relative change is always negative 11%. So we have exponential decay, all right, because we have a constant rate of a constant percentage change. So 5 years from now, Arca and Casey want to trade in the car with the lowest value. Now remember, Arca's had their car for 8 years. Add 5 more, X is now 13. Casey's had the car for 4 years. Add 5 more, X is now 9. So this is what we're comparing. So for Arca, we've got Y equals 21,900, the decay rate to the 13th power. Arca's car is worth 2270.26. Still not a bad value. Casey's, now we didn't find a model. Casey started at 16,000. That's a bad color. Let me get a new color that you can actually see. 16,000 decreased at 11% a year, so we're at 0.89 to the X, and we're finding this after 9 years. So after 9 years, Casey's car is worth 5605.70, and therefore, I don't know why I circled that one. If they want lowest values, they should get rid of Arca's. And that car's been around for 13 years. How much longer is it going to survive? That's another question, especially if you can get some value out of it. So, yeah, there you go. 16, last one. Delta has decided to start a side business as a photographer. She purchased a camera for $1,600. It loses value at 12.5% a year. How long before the camera is only worth half its original value? All right. 1 minus 0.125 gives me a 0.875 decay factor. So my model, I started with a $1,600 camera. It's decreasing in value. to the year. So here's my model. We want to know when half the value. So when is y 800? That's the question. So I'm going to plug in 5. What about 5 years? Well, if I have y equals 1600.875 to the 5th power, I get a value of 820.65. That's a little above, right? Because we want 800. So if I go 6, what about if x is 6? Y equals 1600 times 0.875 to the 6th power. That gives me 1807, which is less than 500. So we are talking 6 years is when it will be only half the value. Because at 5 years, it's still a little bit above. So you might have to go 6, between 5 and 6. And that's the end of that one.